Hello, I'm Siona Bose. Welcome to my channel, Learning Builds Life, and today we are going to talk about covalent bonds. But before we begin, we must understand what chemical bonds are. Let's say any atom is having empty valence shell, means a valence shell is not full. Let's say if valence shell is not full. That means the valence shell is not up to capacity. That means, let's say if it's the second shell, its capacity is 8, but there are a lesser number of electrons. Then there will be a bond formation to help fulfill the needs of the completed valence shell of both of those atoms. So the sharing of electrons occurs here, forming a chemical bond. A chemical bond basically is like sharing of electrons, the valence shell mainly, to fulfill the needs of both those atoms of a complete valence shell. Now we will move on to covalent bonds. Covalent bonds are basically the same theory of any chemical bond, that is, the sharing of valence electrons to fulfill the need of a completed valence shell. Electrons to the need of a complete valence shell. Keeping this in mind, let's take an example of hydrogen, H. We have, it means actually in hydrogen, there is one electron in the first shell, one electron, but capacity is 2 electrons. So another hydrogen atom comes together, then they both overlap to fulfill the needs. Like this, a sort of overlapping occurs to fulfill the needs of 2 valence electrons in case of both those hydrogen atoms. Now there are different ways we can represent hydrogen. Firstly, the simple formula H2. Then we have the Lewis dot structure. Like this. And we have the structural formula. The structural formula is like this. And it consists of a single bond. Now we could take the example of oxygen because there is something different. In oxygen, there are 6 valence electrons. But capacity is 2. Capacity is 8 valence electrons. Capacity is 8 electrons. Over here, what happens? They try to fulfill, but we need two pairs of valence electrons to fulfill the need of 8 electrons in both of the atom's valence shells. So here we have a double bond. Now we will talk about interesting valency. Valency is basically a very easy concept. It is the difference of the capacity of that specific shell, like let's say it's the second shell, so the capacity is 8 electrons, and let's say number of electrons in that shell currently is 5, like in case of nitrogen. So 8 minus 5, that is 3, gives us the valency of nitrogen. So basically, you can remember valency with this formula. It means it's not a formula, but it's really easy to remember. Valency equal to capacity of valence shell minus number of electrons in the valence shell One example I already gave of nitrogen. Another example is of oxygen, whose capacity is again 8 electrons, and the number of electrons in the valence shell is 6. So 8 minus 6 gives us 2, which is the valency of oxygen. Now we can have a short recap. So, chemical bonds are basically, they form chemical bond when the valence shell is not full. There comes a reactivity. That's the reason why inert gases don't react, since their valence shells are full, so they don't have any reactivity to form any kinds of chemical bonds. Now moving on to covalent bonds, it is having the same concept of sharing the valence electrons to fulfill the need of a complete valence shell. If we take an example of hydrogen, it has only 1 electron in its shell, 1 electron in the first shell, whereas capacity is 2. So 2 hydrogen atoms come together to fulfill the need of a complete valence shell with 2 electrons for both those atoms. That's where the reactivity comes, since the valence shell was empty. There are different ways we can represent H2. Firstly, the formula, Lewis dot structure, H, colon H type, and the structural formula, H dash, like that. So that is having a single bond. Now, if we take a look at oxygen, it has 6 valence electrons, and capacity is 8 electrons. It has a double bond because we have to share 2 pairs of valence electrons to fulfill the need of a complete valence shell, which is of 8 electrons. So O with the double bond attached to O, like that. And valency is basically capacity of the valence shell minus number of electrons in the valence shell. Like 2 examples. Nitrogen, whose means the capacity is 8 electrons, number of electrons present in valence shell is 5. 8 minus 5 gives 3 as the valency of nitrogen. And for oxygen, again, the capacity is 8 electrons, and the number of valence electrons present is 6. So the valency is 8 minus 6, which is 2. Now you may take a look at the board. Hope you enjoyed this episode, and please like, share, and subscribe to my channel, and stay tuned for more videos. Thank you!